Hello. So in the last few videos, we've been talking about the double angle trig identities, and in this one I wanted to give an example for the sine double angle identity. Let's refresh our minds on that. We learned that the sine of 2 times some angle x is going to be equal to 2 times the sine of that angle x times the cosine of that angle x. And this is going to be primarily a numerical example. I don't want to get into some kind of word problem. If I find a good one in a textbook, perhaps I'll use that in the future. But for now, we're just going to be dealing with this. And I'm going to say that we know, let's say that the sine of x is equal to 3/8. And we're meant to find out what the sine of 2x is equal to. Also, this is going to be in quadrant 1. So the cosine will also be positive. All right, so the sine of 2x, what's that going to be? Well, we can just use our formula here. That's going to be 2 times the sine of x times the cosine of x. And we already know the sine of x, that's 3/8. So this is going to be 2 times 3/8 times the cosine of x. Now this is still pretty straightforward. If you look back to our Pythagorean identities, you will recognize that, I'm going to just write this off here, sine squared of x plus cosine squared of x is equal to 1. So using that, let's go down here and use that to find cosine of x. So cosine of x will be equal to, well, let's write this whole thing out. Cosine squared of x, and we can add either way. Cosine squared of x plus sine squared of x is equal to 1. Let's plug 3/8 in for sine of x. So that means that cosine squared of x plus 3/8 squared is equal to 1. Let's simplify this a little bit. Cosine squared of x plus 9/64 is equal to 1. But I'm not going to write this as 1. I'm going to write this as 64/64 so that we have some easier simplification in the future. So then I'm going to subtract 9/64 from both sides. So I'm just going to cancel that and subtract 9/64. So this is going to be cosine squared of x is equal to 64/64 minus 9/64, which is then going to be equal to 55/64. If we take the square root of both sides, we will find that cosine of x is equal to the square root of 55 divided by 8. And now I would say plus or minus because we're taking the square root here. It could be plus or minus, right? Because if it was a minus, we'd be squaring that and the minus sign would go away, except that we know that we are in quadrant 1. So cosine is going to be positive. So we know that our answer is that cosine of x is equal to the square root of 55/8. So now we can plug that in back up here with our other formula. Let me just get the orange. So we know now that this thing here is going to be equal to, I'm going to just bring this down here, 2 times 3/8 times the square root of 55/8. Cool. We can still simplify this a little bit. This is going to be equal to 2. Well, let's multiply 2 by 3. Actually, let's just get rid of that. Yep. So let's say that that's 6 times the square root of 55, right? All I'm doing is multiplying the 2 by the 3. And let's multiply the 8 together. It's going to be 64. We can divide the top and the bottom by 2. I did a bit, that is a bit redundant, I suppose. But this is going to be 3 square root of 55 divided by 32. And this is our answer for what the sine of 2x is. Notice that we never figured out the angle. We just knew, I mean, we could with a calculator take the arcsine, but let's say that we're not dealing with our fancy arcsines and such. We can get an exact value without decimals that you get in the calculator, 3 square root of 55 over 32, using this method here. And while from this example it might not necessarily be clear what the real life examples of this are, it comes into use, I'd say, mostly in calculus, which of course has all tons of applications in physics. But as we get into other, what I feel are somewhat more important identities, at least in their format, that come from these identities, I think that perhaps the use will become more clear in terms of how these formulas actually help a better understanding and use of math. So in the next video, we're going to be going into an example of the double angle identity for cosine, and I'll see you then.